Welcome to the WAN. The biggest difference, in my opinion, between ICND1 and ICND2. In ICND1, the breadth of knowledge is just tremendous. I mean, you learn about a ton of stuff: VLANs, switching, routing, network address translation, access lists, subnet. I mean, just blah, 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 just topic after topic after topic. But it's all focused around a single site location. When you move into ICND2, you go deeper into all those topics. You start learning a lot of the troubleshooting, but the biggest step that you take is you now go, okay, we are now connecting multiple offices together using the WAN link. So think of this as your introduction to wide area networking. First thing we're going to talk about is where is the WAN connection? Where does it fit? How does it change? I mean, it's shocking for a lot of people when they find out that the WAN link doesn't have MAC addresses. And they're like, well, if there's no MAC addresses, how does it work? How do they, how does ARPs work and things like that? So we're going to talk about that. We'll look at the physical WAN pieces so you know what you're walking into, physically speaking, like, okay, what's that box do when you get into a business connected to a WAN? And then we'll look at the types of WAN connections, a lot of the advantages and disadvantages of each one. WAN connectivity enters the picture when you go beyond that single site location and start expanding. So your company's growing, you find business opportunities in regions beyond your local area, and you need to bridge those new offices that you're building into the corporate network. Well, this little line here could be a mile, it could be 100 miles, it could be 1,000 miles. Essentially, it's far away, and you can't run an Ethernet cable that far. That's where you come into the connection of the WAN. Now, let me just bring up the MAN, which always feels funny when you say it. There's the LAN, local area connection. There's the WAN, the wide area connection. And then there's this technology. It's very rare that people even use the term, which is a MAN, a metropolitan area network. It's describing connectivity within a metropolitan area, because nowadays there's a lot of carriers that run fiber optic cabling under the streets of a metropolitan area, so you can lease that fiber from them. So I would just kind of take the MAN. Right? The MAN is lumped into the WAN. That's what most people do. Okay, it's far away, so we're using some other kind of technology. Now, up till now, we've talked solely about Ethernet connectivity, which could use, I would say there's two major, well, maybe even three major kinds of physical connections. You have Cat5, Cat6 Ethernet, right, that we've run into. We have fiber optic cabling, which is nice because you get some nice long reaches with using light and a lot of bandwidth. And then you have Wi-Fi. Wireless. These are three different kinds of physical connections that bridge us in. But when you get it into the data link layer, it's all the same stuff. It's all MAC addresses, right, that we're using to identify what device you are on that Ethernet network. Well, when you get into the WAN, you start moving beyond the Ethernet world into new types of layer 1 and layer 2 connectivity. First off, we exchange our Ethernet connections, physically speaking, for a serial connection. Now, it's not all WAN links are serial, and I'll explain more and more as we get into the physical connectivity of WAN connections. Actually, that's on the next slide. But a lot of times you'll see these serial connections come in, and at the data link layer, we now have all kinds of different languages depending on what WAN encapsulation you're using or WAN connection type you're using, and they all have different advantages. Again, more on the advantages of each one of these types later on in this nugget. But for now, just know that there's different kinds of WANs that you can buy, and each one works a little bit differently. Now, a data link layer, we're used to Ethernet, which uses what kind of address? A MAC, right? We're used to MAC addressing at the data link layer. Well, when you get to the WAN world, as I already mentioned, MAC addresses are gone. All these technologies don't use MAC addresses. For instance, Frame Relay will use something called a Data Link Connection Identifier, DELC. ATM uses something called a VPI VCI pair. I can't talk and write at the same time. VCI pair. You can start. There's plenty not even listed here. Like MPLS will start using tags. You start getting into these different kinds of addresses at layer 2, and you're like, wow, everything's different. Well, yeah, everything's different, but it's all the same. It's kind of like, okay, so instead of saying MAC, I say DELC, right? Right. And it works a little different, right? Right. So it's the same concept. It's just an address that identifies the other end. We just start using different styles of identifiers depending on the WAN link that we're using. Again, more on this later. Now, these WAN links allow us to access the internet or other offices. So these are our connections out of our site. Many different types and prices. That's going to be what we start breaking down. All right, let me get a little more practical now. I was so biting my tongue on that last slide. I'm like, I want to speak so much more, but I have individual slides on this. This is. You're like, what is it? This is the physical connections of a serial-based WAN connection. So before we even get here, let me draw up what this looks like. Let's say you have a company here. Purple company. It's like George and his purple crayon. Maybe remember those books from when you were a kid. So we got our company. Out here is our front lawn, our green grassy trees. Happy little trees and all that kind of stuff. So the service writer, you say, okay, service writer X, I want a connection. Their truck pulls up and guy gets out. He pulls out a shovel, digs some trenches from the street or wherever their connection point is up to the office, and they install a little wall jack right here or something like it, a dangling wire from the ceiling or something, most likely a wall jack. That's where we enter right here, and they call that their point of demarc. How many of you heard that term before? Demarcation point. What does it mean? It means this is where our responsibility ends. If something on this side of the demarc breaks, customer, you pay for it. If something on this side breaks, we convince you that it's on the other side and you pay for it anyway. But specifically, the service routers are supposed to cover all of the connections here. So let's start there. So this up here represents the wall jack right here, where the service router comes in and says, okay, here is our point of demarc. That is our line. Now, I'm going to take you the old school route first, right? So you take that line, that port from the service router, take an Ethernet cable and plug it into a device called a CSU DSU. Now, keep in mind, I'm in old school land. Now, these things are still all over the place in the real world. You'll see CSU DSUs. What are they? It's just a really expensive, fancy modem. I always think of it just like a cable converter, which takes this connection right here and converts it over to a serial cable type, where you start getting into the politics of vendors, where over the years, and we're talking decades of time now, right, where they've come up with all these different kinds of connectors. You start getting like V.35. I mean, there's like 5 different major connector types that the industry started solidifying on. I said V35, and I'm like, and I don't remember the rest. I mean, you can look them up. Cisco actually calls their interfaces 5N1. They don't use that term much anymore because serial connections are just fading away. But V35 was the most popular connector type. So this end of the cable would plug into the CSU DSU. Now, this guy really just converts this cable to this cable, but it also runs diagnostic tests on the line. It also does the DCE functions of a serial cable. What's that? DCE end of a cable provides the clocking for the line. So this is the one that the service router configures to tell your device how fast it's able to send. And that's really, the service router says, okay, pay us more money. We will tell that DCE to increase the clock on your line, and now you can send faster. And that's how they make their money. So okay, line comes in, plug it into the CSU DSU, right? CSU DSU, you go buy whatever serial connector you need. So it'll plug into the back of this, and then come over here and plug into one of 2 different kinds of serial interfaces that Cisco supports. Now, if it looks like a lot more gibberish just showed up, it did. My 4-year-old daughter came in the room and said, "Daddy, can I color on your screen?" And so she did. So she also made this right here and was really amazed when I showed her that we could change colors. And actually, she selected an option on this page that I don't even know how she did that. That's pretty amazing. So getting back at it, this right here is a WIC 1T, which essentially means it's a WIC card, WAN interface card, with 1 port on it. And so this is a 2901 route. I actually just took a picture of it and then kind of cropped off the side there. But 2901 has 4 of these slots right here. So I can take, 4 of these different kind of cards and put them in here. This is the older style connector. It's actually known as a DB60. because if you look really close, there's 60 pins. Matter of fact, that's exactly what that matches to. That's a DB60 connector. So you would buy an industry standard end that would plug into the CSU DSU over here, and then from there stretch that cable to the Cisco proprietary DB60. And by the way, buy these cables from somewhere else. You'll pay hundreds of dollars from Cisco for them. You can get them for like $15. But anyway, you'll connect that proprietary connector to this, plug that into your router, and shazam, you have a WAN link. Now, this one right here, this is actually known as a WIC-2T because Cisco got smart and was able to jam 2 serial interfaces per card, which doubles your impact with one of those. And they actually call that the smart serial connector. Different kind of cable required, but essentially it would just be this end, and on this end you would have a smart serial connection and plug it in there. So to follow path one more time, we have the wall jack coming into the CSU DSU, old device. CSU DSU has this cable that then converts from the industry standard connector down to one of 2 Cisco proprietary connectors. You plug that into the router, and now we have our router, which is sitting in Office A, that goes through the wall jack and goes through that service router and connects over here 1,000 miles away to Office B, and allows that kind of communication. Okay, that's one style that you can use. This style is a little more common now. Well, I won't even say that, but you'll see it a lot. Okay, it's more common. This is actually a integrated T1 CSU DSU. So this, as I keep saying, is old school. And as technology evolved, they figured out how to put all the functions of this onto a chip on that card. It's not too far to imagine because if you think back to computers, they used to be the size of a room and now are the size of an iPad or something like that. So technology just progresses. Now this, you'll actually see, if you ever get one of these cards, you'll see it zoomed in. It says T1 CSU DSU on there. You can just plug that straight into there, and now you can go straight from that wall jack into that card, and you skip all of this conversion in between. It's a little bit more common. You can buy those as T1s or as E1s ports, which that's where you got your 1.5 megabits per second or your 2.048 megabits per second on the E1 side. That now leads us into understanding the kinds of connections that you can have. They break down into 3 big categories: lease lines, circuit switched, and packet switched networks. Think of these as like umbrellas of technology. I'm actually going to start off with the circuit switch because it's one of the oldest kinds of technology. When you know you're in a circuit switch world when you hear that world brings flashbacks, right? I actually used to run a Commodore Amiga bulletin board system, BBS, back in the day before the internet was the internet. So I was used to hearing that sounds, and that's where you got the dial-up modems and ISDN, which is kind of on-demand circuits. So essentially, there are still parts of the world that have circuit switch connectivity, and it makes a great backup connection. I'll explain in a second. But that's where you have, well, actually, most of the time you'll see it drawn like this. You've got kind of a dotted WAN link there, representing that this is a temporary circuit. Essentially, when something has traffic that it needs to send to the other side, it will dial up the connection and send the traffic. And once what's called interesting traffic has stopped being needed to be sent, that's horrible English, but you get the idea. When the interesting traffic stops, it disconnects the circuit because you're being charged for that circuit. A lot of times it's long distance, or it's consuming resources that you would rather give up, make available for other things. Now, modems used to be everywhere. That used to be how we connected to everything. Now, the biggest drawback of circuit switches is the bandwidth constraints. So we're now, the kind of bandwidth demands that we have just don't measure up to this. But let me show you, this is what I was going to say, where this does come in handy. Let's say you've got a rack of equipment, right? All of the Cisco gear. You've got your internet connection over here. You're going to your LAN over here. All of your switch ports going to all the different areas of your network and all that, right? So you maybe are a remote Cisco employee. That's very common because sometimes to keep a full-time Cisco person at one site, it's not very productive for resources. So you're working remotely, and all of a sudden the internet connection to that site goes down. Well, now your connection in has been severed, so you don't know if is it the internet service provider that has gone down, or did somebody unplug a cable? I mean, you don't know any of those kind of things. So what sometimes people will do is set up a modem connected to just an analog line. Here's the PSTN, Public Switch Telephone Network, and you sitting out here will pull up your modem and dial in. You actually dial a phone number to get into that modem, and that modem connects into. You've seen the routers, right? The routers have console ports where you configure them out of the box, but a lot of them also have the auxiliary port. The auxiliary port is designed for a modem connection, so you can actually come in to a router, and you're typically going to call that router an access server. And what that router is a specialized router that just has these things known as octal cables. And what they are is just, let me show them to you. I'm just going to go to Google Images and type in octal cable here, and it gives the idea. I mean, there's a schematic of it. That's what it looks like. So essentially, let me just scroll down here. This is actually, I had one of these. This is a 2500 series router. You can see kind of this one has two of those big old connectors. So one of these would plug into one of those, and it has 8 connections coming out of it, and those are designed to go to the console ports of your devices. So you can actually modem in to your access server, and then do what's called a reverse telnet. It's a weird, I'll say a weird phenomena, but it's a weird way of accessing it. But what that does is land you on the console port of all these devices, so you can get to them even though your main connection into the campus is down. It's amazing for troubleshooting. So you still see a lot of those circuit switch. I would say the benefit of them is their reliability. I mean, the circuit switch is relying on the public switch telephone network, has been around for eons, tried, proven, and true. That's a great solid backdoor. And limitation is bandwidth. You're not going to get much out of it. Now, up here we have lease lines. Second one, very, very, very popular connection. Now slowly fading into the sunset. This is where you have dedicated bandwidth between locations. Now, this is when somebody says, I have a T1 line. This is most of the time what they're talking about. This is their line. T1 equals 1.544 megabits per second of bandwidth, and it's mine. Nobody else uses it. Even if I'm sitting there and I'm not using it, nobody else is using my bandwidth. The service provider dedicates it to you. It is one of the most reliable connection types, but Choo-ching, it's the most expensive connection types out on the market. Now, I gave 2 examples right here, T1 and E1 CAS. That stands for Channel Associated Signaling. That's just how it does it. And briefly, behind the scenes, these things are built with these channels known as DS0s. Anyone heard of that? Matter of fact, T1 is technically known as a DS1, which is 24 DS0s all bundled together. DS0 is a single channel. It has 64 kilobits per second. Originated from back in the day when they were trying to figure out how to make digital phone communication work. And they found out that 64 kilobits per second is what you need to send the sound of human voice and make it understandable and make it able to sense the tone. And so these were really built from the phone network and channels for the phone system, and eventually converted in to a data style connection to where we can use those same channels to send data communication, bundling together. I mean, DS1 is just one example. I mean, they actually have, you can go to like a T3 line, which most people think it's 3 times the T1. Actually, it's not. It goes up to 45 megabits per second of bandwidth, taking a whole bunch of DS0s and bundling them together. So in this, I mean, it gets into optical, where you start getting into OC, I'll just go for the big one, OC 192, but you're looking into the $5, $10, $20,000 a month price range by the time you're getting up there for that dedicated bandwidth. So very reliable, very common, matter of fact, this is the one thing we talk about how to configure to start off our WAN links. We'll look at that, and then we'll start getting into some of these guys, the packet switch network. These network connections are the darling of the industry because they're shared, making it cost effective, but guaranteed, making sure that you're going to get something that you're paying for. I mean, when most people think of shared bandwidth, they think of a hub or like cable modems. Cable modems, when you're sitting in a neighborhood at 7 o'clock at night, it slows way down because cable modem providers will say, yeah, we give you 50 megabits per second of bandwidth, guarantee none of it. To where when everybody's using the network, it all slows down because it's this big shared, not guaranteed system. But with this, you really have this kind of cloud connection. Now, it's hard to even draw a cloud anymore because everything's cloud technology now. So it's just, everybody's like, what's that mean? Cloud just means a whole bunch of people connecting into a service router. So this is a service router. Now, mind you, they could be, but I'm going to say not in this case, an internet service router. This is a service provider that is connecting privately your connection. So you are right here. Let's say this is your office, and this is me down here, and we want to have our connection. But this company also has customer one, they have customer two, all this kind of stuff. What they'll do is they'll actually build something called a virtual circuit. It's going through their cloud, their mesh of connectivity, and they're making our devices believe, and they're securing it in such a way that they are connecting directly together, and we're not going to accidentally send something that ends up over here at our biggest competitor, customer two, something. So we can have these connections going between our offices, and as we grow, let's say we add another guy. We'll just put G for guy. I can then bridge my connection over there and allow you and me. I'm trying to remember my little acronyms here to connect everybody together. You can actually bridge those connections. Now you are actually going through this big old cloud of bandwidth. Just throw gobs on here of bandwidth available, but the service provider will guarantee only a certain amount to you. It's what you pay for. You say, I want a 10 megabit per second guarantee, and they're going to say, okay, you will get at least 10 megabits per second. Chances are you can actually even go above that, and they call it bursting above that and getting more bandwidth, but you got to send on average about 10 megabits per second, and you can get this at a price that is far less than a lease line if you do it that way. This also gives us the ability to have one interface, let's say serial 0/0, that can connect to multiple locations. So instead of lease line, I have to have serial 0/0. It is a point to point. That's the lease line. Point to point only between that. So this only goes there, and then I have to buy another interface. This one only goes there, and I can't optimize my bandwidth because I dedicate 1.5 megabits per second there. I'm just saying T1, right? 1.5 there, and if this one isn't being used at all, and this one's maxed out, I don't gain much benefit. Whereas in this, if I provision 3 megabits per second, I probably would get it a little cheaper. But now I can get 3 megabits per second to the site, to where it's one connection to connect. You see what I mean, right? Right. So one connection to connect to multiple locations, I can kind of share that bandwidth between them. So very cool. So frame relay, ATM, a couple examples of packet switch technology. We'll dive into frame relay a lot more coming up. We actually have the whole section of nuggets dedicated to just frame relay. For now, I want to get into the lease line connections, which are so simple to set up that we can squeeze it in right at the end of this nugget. So let's just paint the picture. I mean, you're going to start seeing topologies like this all over the place. Let's just make it real and kind of combine everything we were talking about. Router 1 is sitting in Arizona. Router 2 is sitting over in California, right? Router 1, if we were to actually expand out what this looks like, I mean, Router 1 is sitting in a company in Arizona. We've got that same green grass. We got that same tree, the same truck we talked about earlier, same guy that installs the wall jack, and there is our router in Arizona. And over here, coming out in California, we've got another building, and again, that mirrored setup. Same funny tree, same grass, same truck, same wall jack going in, and over there we've got our connection in California we plug our router into. That's all of what's represented by that WAN link. So what we're doing here is essentially using somebody else's network that they've paid for, that they've dug up streets and all that. We don't want to dig up streets. We're paying to use their network to connect these devices. They deliver it and they hand it off to us. Now, how do we configure it? Well, this is going to go into a serial port, and let's go ahead and bring up our connections. Here is router 1. I'm going to do a quick show IP interface brief, and all I've done is gone in and configured. Let me make this a little bigger. Gone in and configure an IP address on fast Ethernet 0/0. That's our LAN network over here. Serial 0/0 is currently down. Now I'm going to type in a command. Now this picture, this whole topology actually came out of GNS3, which I know you've probably heard about, the emulator for Cisco, allowing to emulate just about anything. So in GNS3, the WAN links are a little bit funky. Let me show you here. I'm going to do a show controllers serial 0/0. Now, show controllers digs into the nitty-gritty physical stuff of the device, and will actually tell you what kind of cable is plugged in there. And I can see that I actually have a DCE cable plugged in. Let me tell you, that's not real. That's not real. In the real world, you do not have DCEs plugged into you. In the real world, you remember from our topology, you have the CSU DSU that is maintained and run by the service router. That is the DCE end of the cable plugged in there, and then there's your router. And same thing over here. If I go to router 2, bring up that connection, do a show controller serial 0/0, it's showing that this side is also, you see it fly by, DCE clock rate set at this. This is just because when they created GNS3, matter of fact, when they created Dynamips, which runs GNS3, they figured out a way to emulate, and however they do it, they use DCE on both sides. That's not real. You'll never see that in the real world where you have two sides going to DCE. I would say in the real world, you do this show controller command, and it's going to show you that you are the DTE, the service provider. You'll never even be able to see the service provider, right? That's their side. That's their configuration. So you're the DTE, and it'll actually report their clocks being received at such and such speed. So it will actually give you what clock rate the service provider has set for you. Now, if you're in a lab environment with some real devices, you can actually get a back-to-back serial. And now I'm using emulation right now, but you can get a back-to-back serial connection. I'm going to take you to everybody's favorite cable place, monoprice.com. One of the things that they have there, let me see if I can quickly find it. Let's go to networking. And they have Cisco serial cables. See this right here? And they're showing right here, this is a DB60 crossover cable. So if you get one of these guys, one end will be, you can even almost make it out there. You'll see one end is actually imprinted on the plastic, DTE and DCE. Hey, there we can see it now, DTE and DCE. So the ends are physically different. And when you plug them in, one end will act as the DCE, and that just means you have to type in, if I could write there, you have to type in the clock rate command. DTE will be the other side, which sets the clocking for the line. Let me go into the configuration mode one more time. I'll do a show run interface serial 0/0. And you can see that under that serial interface, now GNS3 did this for me. It's not normally part of the configuration. This is where you go in and set the speed of that circuit. Okay, so just to get the GNS weirdness out of the way, let's now bring our interfaces back up. And I'm going to show you configuring HDLC. Now, what is that? It stands for High Level Data Link Control. What it is a Cisco proprietary. So that means you've got Cisco routers on both ends of the connection that you are using to communicate. The beauty of HDLC is its simplicity. So again, these routers, you're seeing the configuration of the interface. It's essentially not configured. It's shut down right now. Let me show you configuring HDLC. I'm going to go into global config on router 1, interface serial 0/0, which is what's connecting between router 1 and router 2. And I do IP address 192.168.2.1. and type in my subnet mask. No shutdown. Come over here on the other side. Let's go into global config mode, interface serial 0/0, IP address 192.168.2.2 on the other side, right? That's router 2, no shutdown. That, my friends, is configuring HDLC because it's the default, and by default it's built for simplicity. It doesn't have hardly any overhead whatsoever, but being that it doesn't really have any features to it, it just works. I mean, if you've got two Cisco routers and you just want them to connect together, you can now go ping 192.168.2.2, right? And it just works. Now, you can say, well, I didn't see anything where you typed in encapsulation HDLC. Let's do a show interface serial 0/0. Type in this command. You see it right there. HDLC is right there on the interface. So it was there. Now I could go in. Let's go interface serial 0/0 and type in encapsulation and hit the question mark. Because there's all kinds of encapsulations. HDLC is one of them. But I only have to type that in if I've changed it in some way, because that's what it is out of the box. So that's good. That's good if I have two Cisco routers and I don't really care. So PPP, what's that? I would say it's the planet's most popular protocol. But really, it stands for the point-to-point protocol. It does the same thing as HDLC, but it is industry standard. So I can have my Cisco router connecting to whatever mystery brand is on the other side, and PPP can be the common ground. Piece of cake. I just go encapsulation, PPP, enter on both sides of the connections, and it'll switch over. Actually, before I do that, I want to show you this. Watch this. See, I'm getting status message. Let's do a show IP interface brief. So what I've done, and let me do it again. What I've done is I've changed the encapsulation to PPP on one side. Look at what's happened. Serial 0/0 says status is up. What does that mean? It means I'm receiving clocking signaling. The interface is alive. There's something there physically, but I look at the protocol and it says it's down. Now remember, I always say physical data link. Physically we're good, but data link we're not talking the same language as the other side. And you'll notice on the other side, if I do the same command, show IP interface brief at wrapped around, make this a little bigger. Show IP interface brief, I can see this is reporting a similar status until I go into serial 0/0, and you guessed it, encapsulation PPP. Now, what's going to happen is those two guys are going to realize, hey, we're talking the same language now, and poosh, we'll see the interface come back up on both sides. Hit the up arrow, not there, and how about there? Now I can see the status is up, and I can ping through to the other side. Now, what's the big deal about PPP? Well, PPP, in addition to being the industry standard so everything can use it, it supports features. One of which we're going to talk about in this nugget. We're going to, as you get into the CCNP, you can start getting into some of the others. Just to give you an idea, the one we're going to talk about in this nugget is authentication. Authentication, making sure that the other side is who they say they are. The ones we're not going to talk about includes multi-link PPP and compression. I'll give you a flyby of what they are. Multi-link PPP allows you to take multiple WAN links and combine them into a single connection. So I can say, okay, well, I'm going to take these 4 T1 lines that I have sitting here between these two sites and actually splice together the bandwidth to where instead of 1.5, 1.5, 1.5, I've got all these individual links. It actually splices them together to act and get the bandwidth of a single, would that be 6 megabit per second connection, right? 3 or 4 times 1.4. So it kind of combines them all together. That's known as multi-link PPP. The other one is compression, and compression allows you to literally smoosh down the data before you send it to the other side. So essentially, it's a trade-off. You're trading CPU for bandwidth because you're costing your router processor cycle, smooshing the data down and desmooshing it, decompressing it, desmooshing. Got to make up words. Desmooshing it at the other side, but in the end, you end up sending less overall between the two. I will say very rarely anymore do I see compression being used. Multi-link PPP is still pretty alive and well. But let's get back to why we're here, which is to talk about authentication. Again, making sure the other side is who they say they are. So this, if this is a lease line scenario, we can do authentication before router 1 allows router 2 to connect in and thus access all of these resources and vice versa. They're going to validate that they really are the right R1 and R2. Now, let me back up a little bit more. Lease lines is not you can do it. You can do it. We're going to do it right now. And it's expected of you to do it when you get to the certification exam. But lease lines are not the normal place to do authentication. Why is that? Well, the only way somebody's getting on a lease line typically is if they come into your IT department, kick open the door, shoot the IT administrator, pull the router off the line, dispose of your router, put on their router, connect it, configure it the same, and bam, now they're accessing the other portion of your network. But at that point, you're not concerned about that. You're concerned about the dead IT admin at site A. And you want to address that one first. Where authentication usually comes into play is on dial-up circuit connections. So for example, PPP can also cross over into the circuit switching world. So here's our modem, which connects into the PSTN. We allow dial-up access for maybe our mobile users who are actually still using dial-up modems, or maybe it is our backup should everything go down. I want to make sure that I have a backdoor into the system so I can do administration. Well, either way, as soon as you expose your router to the PSTN, it's going to get a phone number, 555-1111. We'll say is the phone number, and anybody can dial in, and if you don't have authentication, bam, they're sitting there on your router in configuration mode. What do they want to do next? So no, we want to authenticate them and make sure that they type in a valid username and password before they can do that. So that's normally where you're going to do it, and I will say, just being upfront with you, honestly, CHAP and PAP authentication aren't done that often anymore. But it's still valid. It's still something that's out there. So Two ways that you can do it. Now, I said CHAP and PAP. You're probably like, what do you say? CHAP is actually a second generation authentication. There is another one called PAP that nobody uses anymore. Password Authentication Protocol is what it stands for. It is clear text. I mean, if you're using PAP, router 1 comes over and says, hi, router 2, I'm router 1. Router 2 says, yeah, what's your password? He goes, my password is Cisco. And router 2 looks at its database and goes, oh, great, that's the right username and password. You are allowed in. Well, meanwhile, somebody in the middle, evil hacker right here, just captured that data using Wireshark or whatever mechanism because it's all clear text for them to see. Well, people said, well, that's no good. Let's come out with CHAP, the Challenge Handshake Authentication Protocol, which some people say it's encrypted. Actually not encrypted. It's plain clear text. However, the password is never sent because it sends what's known as a hash of the password. In a nutshell, what happens is this router over here, when it sends the packet, will take a whole bunch of data from that packet, put into a blender. It says, okay, I'm going to put some random numbers in there. I'm going to put what's known as the pre-shared key or the shared password between the two. And that's one of the requirements for CHAP is router 1 and router 2 have the same password. They kind of have this pre-shared password that they agree on. So we take that pre-shared key, throw it in the blender, throw some other stuff in there, hit puree, and it spits out what's known as a hash, which is just a value. Now, that value is stuck on the end of the data that's being sent over to the other side. Now, router 2 gets that data, right? It looks at it and goes, okay, yum, some great data to chew on, but I would need to validate that this is real data. I'm allowed to trust it. So it takes that data off, puts all the same stuff in there because it's configured. Let's just say the password is Cisco, right? Both sides have the password of Cisco. So it puts, attributes from this packet, the random number, all this stuff that just gets thrown into the blender, along with the pre-shared key on this side, which, again, the pre-shared key is never put in that packet, ever, ever, ever. So that's one of the advantages of CHAP is you never send your password over the wire. What happens is router 2 puts all the same ingredients in there and hits puree and it spits out a hash. Now, if anything is different inside of that blender, which the only thing that could be different is that pre-shared key. So if it has the wrong key on router 2 side, it's going to spit out a different hash, at which point router 2 is going to reject that packet saying, oh, sorry, you failed the authentication. So CHAP is a hashed version, much more secure in the end than PAP. Now, the good news about CHAP is it's very easy to configure between the two. So here's how it's going to play out. Router 1 and router 2 actually use their host name. Now remember, so at some point we would have had to configure, for instance, router 1 to have the host name router 1. So it's going to use its host name as its username. So it's going to come over to router 2 and say, hi, router 2, I'm router 1. Now, router 2 is going to look in its database and it's going to say, do I know a router 1? So what we need to do is create an account on router 2. So we're going to create what's called a username, router 1, and assign router 1 some kind of password. Now, that password has to be the same as whatever we assign the other direction because router 2 is going to do the same thing. It's going to say, hi, router 1, I'm router 2. Again, because it has that host name. And so router 1 is going to look in its database and say, do I have a user account for router 2 that has, whatever password assigned. Now again, the key with CHAP is that this password has to be the same on both sides. Again, can I please emphasize, because once you enable this, every single packet that's sent will have all kinds of stuff in there in that header that the router, when it receives to the other side, is going to take that and put that inside of a blender. It's called an MD5 blender. Turn it on puree, and it's going to throw, and this guy does the same thing before it sends the packet, throw this pre-shared key. That's actually what this is known on, this shared secret between the two in that blender as well, and it spits out the answer. So if somebody, let's say evil person X, is sitting in the middle and captures that packet, they're going to be able to grab a lot of the data from this packet, the numbers that are thrown into that blender and everything. They'll even see what the answer is, because the answer is put in here in clear text. The hash is sitting right there. So this evil person in the middle can get all of that, but it is impossible. That's what makes hashing so powerful. It's impossible to reverse engineer it. I know some of you are mathematically minded and being like, okay, so you're saying they get a bunch of stuff out of the packet that's clear text, right? So it's kind of like they have X, and they get the answer, which the answer might be 53, and so it's kind of like, can't they like figure this out? Can't they? No. They can't. And if they did, it would really freak a lot of people out, because a lot of people trust the hashing algorithm to be irreversible. That's the whole power behind it. So we have to configure the same password on both sides, because that password itself will never be sent across the wire. Okay. Now I know some of you are like, Jeremy, you just said all this. I know it's just one of those things that if you miss it, it's like I don't get it. Okay, so global config mode. Here's what we have to do. So I'm on router 1. I'm going to create a user account. I'm going to say username R2. Password for R2. So I'm creating a user account in my database. Password, let's just say, is Secret Ninja. Now I have to use that same password on both sides of the connection, right? So now I'm going to flip a switch. I'm going to go into interface serial 0/0, which is the interface connecting between these two. I'm going to say PPP authentication, and you can see there's a lot of different types of authentication. PAP was one that I mentioned. CHAP is what we're going to use. We also have, if we're connecting to Microsoft clients like dial-up and things like that, we can use MS CHAP. I'm just going to say PPP authentication CHAP. Now, immediately when I do that, what just happened? Interface went down, right? Show IP interface brief. Interface is now down between the two. Why is that? Well, that's because router 2 just got hit with a sledgehammer. He's just sending packets all day long. All of a sudden, router 1's like, whoa, these are not authenticated. You're down, and it's severing the connection. So router 2 on the same end is also down. Now, okay, you and I are sitting here. We walked into this, we see it down. We're like, how do we know that it's authentication? Well, one of the commands that we could do is debug PPP authentication. We would do a show run and see that authentication is turned on, and we see these messages constantly spitting out on router 1. Authentication required. And that tells me, okay, so the other side isn't giving it something. Well, let's see on the other side, debug PPP authentication, and see what he's reporting. Router 2 is saying, whoa, I'm getting a message back saying no authorization without authentication, unable to authenticate. Why not? Because I don't know. I don't have, it's required, but I don't have anything to give them. I haven't been configured, right? So let's type in you all and turn it off on that side. Okay. So now on router 2, I'm going to go into global config mode and do the same thing. Now, so we're reversing it. We're going to say, okay, well then I'm going to create a user account for router 1, and I'll type in password of, what was it, Secret Ninja? Now this has to match. If you type in the wrong one, it's not going to work. Router 1 password Secret Ninja, and bam, you see it immediately on the other side. It's like bing, authentication. I'm authenticated, and now that the interface has gone to up. We're now doing what's known as one-way CHAP authentication. One side is configured to force authentication, and the other side now has the credentials it needs to be able to do that. But I can do, and this is what most people do, two-way authentication, where both router 1 and router 2 authenticate each other. And I'm going to say on router 2 now, PPP authentication CHAP. So I'm now enabling it here. And now you can see the other side is like, whoa, now they're asking me to authenticate. Now, so router 2 is requiring authentication, and I will because I already have that mirrored user account, and life is good. Our circuit is now up. Show IP interface brief. And I can see that the circuit has returned to operation. I can ping between the two sides, 2.1, and life is good. So if I were you, I would be thinking right now, okay, real world, how often does this happen? Authentication, very rare. Now, okay, authentication in general, sure, all the time. But on lease lines using PPP CHAP authentication, very rare. You just don't see it that often. Now, turning on encapsulation PPP, that happens all the time. Because a lot of times you'll be bringing up a lease line circuit to a ISP or something like that. And ISPs like to be all welcoming. They welcome all vendor routers that they have. So most of the time they're going to be using PPP encapsulation. So you'll just have to do that. But we saw that. It's one command that you type in, encapsulation PPP, to make you compatible with the other side. But knowing to type that command, knowing what that is, that's what we're all about. But overall, lease lines, one of the simplest configurations that we could do. And we'll be very thankful for that when we start getting into frame relay. For now, we have seen the place of WAN connections, what they're all about, even seen the configuration of lease lines. I hope this has been informative for you. I'd like to thank you for viewing.